going to talk about 3,191 minimal operation to make binary array elements equal to 1. First version. The question is, you are given a binary array numbers. You can do the following operation on the array any number of times, possibly 0. Choose any 3 consecutive elements from the array and flip all of them. Flipping an element means changing its value from 0 to 1 and from 1 to 0. Return the minimum numbers of operations required to make all elements in numbers equal to 1. If it is impossible, return -1. Okay, so when we encounter 0, we have to filter. Okay, so use the... Okay. For int I equal to 0, I smaller than n minus 2. If I need a count, I'll call this readout. If numbers I is equal to 0, then numbers I equal to 1, and also I need to 1 plus 1 is equal to numbers I plus 1. If equal to 0, then equal to 1 and 0. Numbers I plus 1 plus 2. Actually, I don't like write this way, but it's fine. Then count plus plus. Now also for the last one, right? So if this for loop finish, and we gonna finish if the numbers are -1. Numbers -1 equal to 0, or numbers -1 equal to 0. The last one, return -1. If not, return the count. Okay, yeah. And for the time complexity is O(n) and square is the O1. So this one is kind of like when you encounter, right? Which means current here you have to, when you encounter to 0, you have to flip. So which means at least 1 0 you need to flip 1 time. And this one needs filling, so the minimum is 3. So you can just to do that. And if previous is already finish again, but for the last one, because you need to flip 3 numbers together, the last one you cannot do that. So which means you can. That's why we need to check this. Yeah. This is kind of like the high level idea about this one, the logic about this. Yeah. Thank you.